Homework Hotline, what is your emergency?
Oh, hello. You're watching Homework Hotline. I'm Becca, a math teacher at Emily Griffith High School.
Welcome. I'm also a math teacher at Emily Griffith High School. My name is Nathan.
And I'm Sam. I'm a science teacher at the Contemporary Learning Academy.
And Sam, we want to welcome you to Homework Hotline.
Thanks so much. I'm really excited to be
Really
here.
great to have you here.
Thanks.
Yeah. So do your math or science homework have you scratching your head? Then just call us. Nathan and I will be answering your math questions.
And I'll be answering your science questions.
And we're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. So give us a call at 720-424-1666. We'd love to get your calls because it helps us answer your questions a little bit more thoroughly.
So you can watch our show in several different ways. For live broadcast, you can watch us on Comcast Channel 22 or go to livestream.com and search for EG Homework Hotline. If you'd like to see some of our past shows, though, watch us on YouTube by searching for DPS TV Homework Hotline.
And the Homework Hotline is sponsored by Contemporary Learning Academy and Emily Griffith High School. One of our EGTC students, or EGHS students, Lily, is also part of our team. Lily, why don't you tell the audience a little bit about yourself?
Hi guys, I am a senior at Emily Griffith this year, and the Homework Hotline wants to be accommodating to those of you who like to turn in your questions on social media. And I help get those questions over to Nathan, Becca, and now Sam. And so, at the top of each show, we also have a trivia question. It can be on any subject, and if you call with the correct answer, you will win a prize. And so, before the end of the show, I would like to hear the correct answer from you guys. So, today's trivia question is, what makes hot peppers so hot? And we will answer that at the end of the show.
Ooh, so if you think you have an answer to that trivia question, or even maybe a guess to the answer, you can give us a call before the end of the show. The phone number's on the top of your screen on the top right. It's 720-424-1666. Also, though, we'd like to give you our other contact information because that's not the only way that you can get a hold of us. You could also get your questions in through social media on Facebook or Twitter at EG Homework. You could text in an answer to the trivia or your homework question at 970-680-3771, or you can even email us at homework@emilygriffith.edu. So a lot of different ways that you can get a hold of us, but if you've got some homework questions, give us a call now and let us know, and we can get you some help. So we've got, as Lily mentioned, she's our social media. Let's check in with her and get some of our questions from the weekend or early this week answered.
Okay, so let's start off with a scientific question. So this asks, why are scientific laws useful?
Okay, well, I guess that is probably me.
You.
So scientific laws, I think that a lot of times we think about both scientific laws and scientific theories, and in some ways those words are interchangeable. But basically it's this: a scientific law is useful. A scientific law is useful because it's something that gives you information about a lot of different things that are happening. So for example, one really common scientific law is the conservation of energy. So the law of conservation of energy states that energy is neither created nor destroyed, it just changes position. And so based on that law, or based on that idea, you can know a whole wide range of things off of that one piece, right? A theory, which is not a law, but again, the definition is fairly close. A scientific theory would be maybe like the theory of evolution. So there is a ton of evidence that evolution is a real thing, and there is not a single piece of evidence that suggests that evolution is not true. All the information that we've found is tied together by the idea of evolution in biology, just like much of the information that we found in chemistry is tied together by the law of conservation of energy or the law of conservation of matter. So laws and theories, again, are something, they're a simple concept that allow us to explain a really wide range of things that are happening. That's as good as I can do.
No, that was really interesting.
So would you say then that like scientific theories are more, I don't want to say open to change, but there's kind of the idea that they could change.
So that's a great
we just
question.
haven't proven it wrong.
I would actually say, so a lot of people would argue that it's still very unlikely that a theory will ever change, but you're right, a law is more accepted than a theory.
Okay.
A law is that the only real difference is the degree of how certain we are. So with a law, we are certain practically beyond a doubt. With a theory, yeah, we are still open to the idea that maybe something could happen. And if anyone could find one piece of evidence that showed that, for example, the theory of evolution was untrue, it would totally undo the theory.
Right.
But we never have found that. All evidence supports this theory, which is that more complex life evolved from simpler life.
Makes a lot of sense. Yeah. That makes a lot of sense. Well, thank you.
Yeah,
I feel like I learned from that one.
I definitely did.
You guys have science homework, let me know.
Yeah, right.
Perfect.
So I think we're going to go back to Lily for maybe a math question now.
Alrighty.
So this one asks, how do I rewrite the following equation in slope-intercept form? Y plus 2 equals 4 parentheses x plus 9 n parentheses.
X plus 9. Okay. So if you go to my screen, I'll take that one. If
Okay.
That's okay.
It's
Thanks.
fine with me.
So this equation is actually currently it's in what's called point slope form. What was asked was to turn it to slope intercept form. And one of the ways to tell the difference between point slope form and slope intercept form is basically what information it's given. Slope intercept form looks like this. It's y equals mx plus b. This is probably the most commonly used equation of a line. And part of the reason is, let's find my highlighter here, is, all right, so this m, this coefficient there, that stands for slope, or represents the slope. The b, or this constant here, is representing the y-intercept, hence slope-intercept. We've got both of them there. The big characteristic of something that is in slope-intercept form is that this y is isolated. And so if we can isolate the y in an equation, and then we can kind of simplify everything so that it looks, you know, all of your x terms are put together and all of your constants are put together, then if we can simplify it, then we do have it in slope-intercept form. So one of the first things that I'm going to look at here to turn it into slope-intercept form is this 4 times the quantity of x plus 9. We want to take that 4 and distribute it to both of the quantities in here. So what that'll look like is 4 times x, which is 4x, and then 4 times 9, which is 36. So we'll put 4x plus 36. That's already looking a little bit more like slope-intercept form. Then from there, again, like I said, we want to isolate the y. So we're going to look at the side that the y is, and it has y plus 2. So that plus 2 is what's preventing us from isolating it. So we're going to subtract 2 from both sides to get that 2 out of there. So now on the left side, we just have the y. And then on the right side, this minus 2, we're going to subtract it from the 36 only just because it's not a like term with the 4x. So the 4x stays the way that it is, and then we'll subtract the 2 from the 36, giving us 34. So now you can kind of see, all right, our equation, it looks a lot like this does. It's in our slope-intercept form. And if we had to even take this a little bit further, we could say, oh, well, our slope is 4, and then our y-intercept is positive 34. So you can see that now it's in slope-intercept form. All it really takes is a little bit of manipulation and making sure that you are doing the same thing to both sides of your question, or your equation, sorry.
Yeah, I often have students asking me why do we bother putting them all in these different forms, but it really in slope-intercept form tells you a lot about just like what the line's characteristics are.
Yeah, exactly. Those are really the two really important things about a line is what is its slope, because that tells you the growth. So if you're thinking of a real life information or situation, it tells you the information of that's what your growth is all the time. And then your intercept is your starting value. So what do you start at and how do you grow? It's really important to me. You're right.
Yeah. I think we're going to go back to Lily for another social media question.
Okay, so this question says that the negative numbers and parentheses are confusing them. So they ask negative 23 in parentheses plus negative 15 in parentheses equals what?
I can take that one, and if you can elaborate maybe when I finish
Okay.
explaining it, that might be helpful.
Cool.
So one of the ways I like to think about this is, well, first of all, let me just write this down, is you mentioned in the question the parentheses are throwing you off. A lot of times parentheses are helpful for kind of organizing a problem or kind of separating. So we can actually take a look at this. And I'm going to leave it like this for a second. It might actually be a little bit more clear as to how we're adding these two negative numbers. So I get this question quite a bit, a lot of struggles with just like negative integers. But I like to explain this by thinking of like a number line. And what we're kind of doing here. So I'm going to draw. This is not going to be the prettiest thing, but I'll do my best. So if you think of this, we can do this either way, but if we think of like negative 23 here as kind of our starting point, I'm going to draw over here a negative 23. And if we kept going to the right, we'd be at negative 22, negative 21, and kind of so on. But when we're adding negative 15, if you think about positive and negative numbers on the number line, when we're adding, we're typically going to the right. When we're subtracting, we're going to the left on the number line. So when I add a negative number, it's kind of like we're moving 15 spaces negatively on the number line. So what we're really doing is going, I could draw all of these, but we're moving negative 15 spaces to the left or in a negative direction. So I don't know if that's quite enough, but we'll see. So I'm starting at negative 23, and I'm moving 15 spaces to the left. And it's actually one more. So in a sense, we're kind of adding the negative numbers. So if I went 15 spaces to the left, I'd be all the way over here at negative 38. So with the parentheses, we could actually rewrite this and say, well, this is the same thing as negative 23 in parentheses. We can just get rid of the parentheses if that's throwing you off. And then what we're doing here is kind of, in a sense, you can think of this as like, if I had a 1 here, we're kind of multiplying positive 1 times negative 15, or just multiplying a positive by a negative number. So I get negative 15. And again, you can think of this as just starting at negative 23 and moving 15 spaces in a negative direction. And I know there's another way to do it with keep, change, but I'm not too familiar with that method.
I can show you. So I'll show a little bit of like
Okay.
a positive negative method. The number line is a great method. I love that method because really that's how the numbers work, is we're
Right.
moving on our number line. You could also, keep, change, things like that. Those are kind of like little gimmicky things to help remember the rules.
Yeah.
It's not really, though, explaining how it works.
Which is why I
like the
kind
number
of
line
try to
is.
avoid them.
Another way to maybe, actually, that would kind of explain how it really works, and I'm going to do it with some smaller numbers just to so that I don't have to draw that
Yeah.
many things. But let's say I were doing -2 plus -5. You can kind of think of the negatives as like, okay, well, I owe $2, like owing something, so owing
Right.
$2. Or another way that I see people do it is they'll write 2 negative signs, saying like, those are 2 things that I owe. And then I also owe $5. Altogether, how much do I owe? I owe -$7. And this kind of method, really what you can kind of see is, let's say I were doing a negative plus a positive. If I did -2 and then +5, 1, 2, 3, 4, 5. If I owe $2 and then I pay you $5, I'm basically canceling out those 2 that I already owe you, and now you're $3 ahead of what you were. So anytime, like you can kind of write, okay, there's -2, there's +5. All of the negatives are going to cancel out the positives, and vice versa. So this is maybe another way to think about negatives and positives. But
That's one
Number
of the
line and
things-
this way are the two really mathematically
Yeah.
valid ways to think about it.
I think thinking about it in terms of money is something that everybody can relate to, like owing somebody money and then borrowing more money from them or paying them back. So I always like using that example as well.
Yep, very good example. All right, let's go back to Lily and get some more of our social media questions answered.
Okay, we're going to do a quick science question, and it asks, how many electrons are in a neutral atom of carbon? And then it says atomic number 6, question mark.
Yeah, okay, cool. I'm just going to pull up an image of carbon really quickly. Oh. So it says that carbon is atomic number 6. If you can look at my computer screen here, possibly. Oh, that is a very tiny 6, or a very tiny carbon there. Well, one's about the same size. But on the periodic table, carbon appears like this. It's C for carbon, that's the symbol for it. And then there's a 6 above and a 12 below. And the 6 above is what's called the atomic number. And the atomic number tells us how many protons are in that particular element, or in an atom of that element. So if there are 6 protons in an atom, it has to be carbon. If there are any more or less, then it cannot be carbon. 6 protons is always going to be carbon. Now the question is asking how many electrons are in a neutral atom of carbon. And so what we need to think about is the idea that protons are positive. And this question is asking about charge. This question is asking about positive or negative charge. A neutral atom is going to be an atom that has a completely neutral charge, in other words, a charge of 0. It's not more positive or more negative. There's an equal amount of negative and positive in that atom.
Kind of like I was just showing with the positive and negative how they cancel.
That is actually exactly right. When I was looking at you doing that, I was thinking I use that exact method for my students to figure out what is the charge of an atom. Because if you have an atom that has, let's say, 3 protons, and you have an atom that has 2 electrons, in the same way you would put 3 pluses, you'd put 2 negatives, and you could see very clearly there's 1 additional positive, and so you'd be able to say, okay, this atom has a charge of positive 1. Now, the person who wrote in was saying that they want a neutral atom, and again, a neutral atom is going to be any kind of an atom that has an equal number of positive and negative charges. So since I know it's carbon, they told me that carbon has an atomic number of 6. That means there are 6 protons, 6 positive particles. So I need an equal number of negative particles. Electrons are my negative particle. I need an equal number of electrons to protons to end up with a neutral atom. So that was a long way of saying the answer is 6. It's the same number of electrons as protons. And that's true of any element. If you imagine any element on the periodic table, gold, for example, is atomic number 79. That means it has 79 protons, which would mean that you would need 79 electrons to have a neutral atom of gold. Does that make some sense?
It does.
Yeah.
Cool.
It does. Very math-like.
Yeah, there is a lot of math and science.
Yes,
so
there
maybe
is.
I'll
There
throw
is.
you guys some
Yeah.
math questions at some point.
Awesome. All right, one of the things that we do on Homework Hotline is we will film shorts that have that outline some topics that might be more basic topics, but maybe some topics that are not as well understood. So one that I did was on percents. So check out what I have to say on that. One thing that I've noticed a lot of middle schoolers and high schoolers struggle with are percents. Percents are actually pretty easy if you think about what the word actually means. If you break down the word, this word per means for each. The word cent, for example, cents in dollars, centipede, means 100, or century. Think about a century has 100 years. So the word percent, overall, it means for each 100. So thinking about that in problems such as this, if I needed to find 7% of 200, what that really means is 7 for each 100 that I have. In this case, I have 200. So that means there will be 7 for the first 100 and then 7 for the second 100. So in my head, I can calculate that I've got 2 7s, which gives me 14. Same idea here. 20% of 400 means 20 for every 100 that I have. In this case, I have 400 So that means I'm going to have 4 20s. And 4 20s together would give you 80. We can also use this idea for parts of numbers, parts of hundreds, such as 50. 50 is half of 100, so that means if I were doing 10 for each 100, I'm going to have half of that if I'm doing 50, because 50 is half of 100. So 10% of 50 is 5. You can do that with numbers like this. 350 is just the same as 350. So if I have 12 for each 100, I have 3 hundreds, so that means I'm going to have 3 12s, plus a half of 100, or half of 12. So 3 12s is going to give you 36, plus that half of the 100, which is going to be 6. So altogether is 42. Welcome back. Hopefully that helped you a little bit with percents and maybe just get a better idea of what they are and how, then therefore how they work. But I believe we have a caller on the line now, so let's take that.
Hi.
Hi, how are you?
I'm okay. How are you? Who am I speaking with?
This is Becca. Thanks for calling Homework Hotline.
Oh, okay. Great.
What-
I have a math question for one of the math teachers.
Okay, go for it. What's your question?
Basically, Marion was having a party. He wanted to rent a ballroom. I don't know if Marion's a boy or a girl, but they paid a flat fee of $750 plus $125 for each hour. Please write the equation to represent the cost of renting the ballroom for Marion's little get-together thing.
Okay, well, let's see if we can help you and Marion. So we know that we're going to be paying this $750 no matter what. So, and you actually kind of said part of the equation when you said it was going to be $750 plus $125 per hour. So that's part of our equation. What the two things that we don't know are the total cost, right? And then we also, what else is it that we don't know about this whole situation?
Well, we don't know if Marion's a boy or a girl.
That's also true, which won't really help us find our total cost. What else do we need to know in order to be able to find how much it's going to cost altogether?
Well, we're going to need that hourly rate.
So we have that, which is $125 per hour. Do we know how many hours, though?
I think it was one of those things where it's like 8 p.m. to question mark. So let's just say 6 hours.
Okay, well, if we don't know how many hours, what we can actually do is we can just use a variable to represent that, since we don't know that, right?
Yeah, so let's just do P for party.
Okay, well, let's call our hour, those are the two things we don't know, and we'll call it P for party. So we don't know the number of hours, we'll call that P for party. And then we also don't know the total cost. What do you want to call the total cost?
T for total cost.
Okay, sounds great. So let's call that T. So to find our total cost, so we'll say T equals, and then we have to, like you said, is we have to pay that $750 no matter what. So $750 plus, and then we know that we're going to have to also pay $125, but the amount of times we're going to have to pay that $125 has, it definitely depends on how many hours we rent it for. So if we rented, let's say we rented it for 1 hour, how much is that going to cost us with that hourly rate? We'll ignore the $750 for now.
Oh, so it's just, if we just do 1 hour, it's going to be $875.
Okay, so without that $750, how did you get that? You did the $750 plus the $125, right?
Right.
Okay, so what if you rented it for 2 hours?
Then you're just going to multiply that 125 times 2.
Right, exactly. What if we were to rent it for 3 hours?
then you could multiply the 125 times 3.
Exactly. So depending on the number of hours that we rent it for, we're going to multiply that 125 times the number of hours that we rent it for. So since we don't know the number of hours, let's just say, and remember we were calling it P for party.
Of course.
Of course. So let's just say we're doing 125 times P, whatever that is. So our total cost is always going to be $750 plus 125 times P, whatever the number of hours for our party is.
Very nice.
Does that make sense?
It makes awesome sense, and I hope Marion, whatever they are, has a fantastic party.
Me too.
Bye.
All right, bye. Thanks for calling. All right, so if you have any homework questions, I did not get his name, I'm sorry, but like he did with Marion, be sure to call in your questions. The phone number is on the top of your screen, 720-424-1666, and you can get your questions answered live just like he did.
And I think we're going to toss it back to Lily again for another social media question.
Okay, we're going to do a quick science one, which I'll pull up a little bigger. It says, what percent of the Earth is covered by water?
That was just a straight up factual question. So with this kind of a question, I believe that the answer is about 80%, but I'm gonna look it up just to be 100% sure here. So we'll just go right to Google and ask, what percentage of the Earth is covered by water?
Do you know how much it is?
I want to say 75 to 80%. I mean,
Yeah.
that's what I was always.
I would have said something more like 2/3, but I didn't know. I don't know.
And 2/3 seems fair also, right? So I'm getting 71%
Okay.
according to the
So we're
US
close.
middle,
We're
yes.
right in the middle.
And that's the United States Geographical Service, so they probably have a fairly accurate number there. And if you just want to imagine conceptually what we're talking about here, what we're talking about is the idea that the continents, so the land masses, actually represent a much, much smaller piece of the surface of the Earth than the water on the surface of the Earth. And that has a ton of different important implications, one of which is that continents actually reflect light, whereas oceans absorb light. And that just has to do with the general color of the continents versus the oceans. And so the percentage of the surface of the Earth covered in water actually is partially something involved in the controlling of Earth's temperature.
Right.
So
That's
if
what I
we
was
had
thinking.
less water, just less water in general, the planet would be colder.
It could get colder. And so
Right.
actually what will happen is as ice sheets grow, at different times in history, ice sheets have grown, right? And as ice sheets actually grow, you get more surface area of continents as opposed to ocean. And you can imagine an ice sheet being very kind of white in color, very good at reflecting light. And so as ice sheets grow, it actually cools the Earth more.
So it just compounds.
It compounds. It's
itself.
what in science we call it a positive feedback loop because one action continues the same action forward. So as the Earth gets colder, more ice forms, which creates
Colder Earth.
which a colder
Yeah.
Earth, exactly, which makes more ice form, which continues that cycle. There've actually been periods in Earth's history where Earth has been called snowball Earth, where a huge portion of the Earth is covered in ice sheets. And that has to do with that very positive feedback loop that I was talking about.
Makes a lot of sense.
Yeah, that's interesting.
That's really interesting. Well, let's go back to Lily and get another question answered.
Okay, so
Learn
this
some more.
one says an area of a triangle is rectangle, I'm so sorry. It says 24 centimeters squared, and the width is 2 centimeters less than the length. Find the length and width.
All right, I can take that geometry question. So if you go to my screen, I'm going to quickly again, I think one of the best things to do, especially for these kind of word problems, is to always draw a picture. A lot of my students want to always avoid this, but it really helps to kind of see what's happening. So when we have a rectangle, we definitely have, a length, and we have a width. And again, I think we talked about this last week, but remember, length and width are interchangeable. So I could call this length width, and I could call this width length. It doesn't really matter. But one of the key things here is to, let's read this problem again. The area of this rectangle is 24. And then the tricky part is we're given a little bit of information. We're not just given the length and width. So we know that the width is 2 centimeters less than the length. So I'm going to come over here and call this width is 2 centimeters less than the length. So again, just trying to set this up so we can kind of see what's happening. So what I want to do, if you recall, the area of a rectangle is going to be the length times the width. And we're going to just plug in what we know here. So the first thing I want to do is say, okay, the area we are given is 24 equals the length times the width. And this is often where a lot of students get hung up once they're good with finding these equations and the expressions. And that we're trying to solve an equation, but we have only one equation and we have two variables. So anytime we have that, what we really need to do is try to rewrite one of the variables in terms of the other one. So right here, we know that our width is length minus 2. So both of these sides of the equation are equivalent. So what I can do, and so I don't run out of space, I'm going to kind of come over here, is I can rewrite, so I'm going to leave my L alone, I can rewrite my width in terms of the length. I know that my width is the length minus 2. So now I have this down to just one variable, and I can solve from here. So what we're going to do first, and kind of what we did before in an earlier question, is when we multiply a monomial times a binomial, we need to distribute this monomial to each term inside. So L times L is going to be L squared, and L times negative 2 is going to be minus 2L. So one of the things that stands out here again is that my highest power is a 2 right here. So I know that this is a quadratic equation. Well, if it's a quadratic, we have a couple ways of solving it. We can use a quadratic formula, pretty common, or we can factor and use the zero product property.
Let's factor that one.
Yeah, let's factor. It looks easier to factor. So I'm going to come down here. The first thing you need to do is, in order to factor this, is set one side equal to 0. So I'm going to move this 24 over to the other side, subtract 24 from here and here. And what I'm left with is 0 equals L squared minus 2L minus 24. And I'm not going to get too into the method of factoring. I'm kind of assuming that you're comfortable with factoring at this point. So I'm going to walk this again. 0 equals, we're going to have 2 factors. And you can kind of do some guess and check in here. But we're going to find our factors are negative 6 and positive 2. Now, I like to do guess and check here. But again, it's really easy to make a mistake. So what I also like to do, and actually I did make a mistake.
I was going to say, that's not
perfect.
right.
What I like to do here is I like to pretend that I made the mistake on purpose because it's a good learning experience.
Of course.
That's what
Students,
we do as
spot
teachers.
the mistake.
Exactly.
I did this on purpose just to see how good you were.
Exactly. So one thing that you should know is when we're doing this, this positive 2 and the negative 6 here, these should multiply to give me negative 24. And they don't. I made a mistake. So I'm going to kind of come back here. This was correct, negative 6. This should have been a positive 4.
Ta-da!
So
there you go.
I'm really glad I made that mistake on purpose, so you can all learn from that. But again, what I'm doing is negative 6 times 4 is 24. Negative 6 plus 4 is negative 2, so that works. And then using the zero product property, we're saying really, and I'm going to maybe go through this a little quickly, is that anything times 0 is going to be 0. So what we can do is say, well, it doesn't matter which one of these factors is 0. Either L plus 4 can equal 0, or L minus 6 can equal 0. And regardless of which one is 0, we're going to get 0 as our product. Mm-hmm. So we solve, we get length as negative 4, or the length is 6. And again, you have two answers here, but it really is important to think about this conceptually and think about, does it make sense for a length of a rectangle to be negative 4? And just think, is that even possible for me to draw that?
No, I'm kidding. It doesn't.
All right, I was like, did I make another mistake
Sorry,
on purpose?
no.
All right, so we can just cross this out. This is not one of our answers. So we know that the length has to be 6. So I'm going to come back up here, and say the length equals 6. So now the problem actually asked us to solve for the length and the width. So we can do one of two things. We can plug it back into our area formula, or we can really quickly look over here, and I have an equation set up for the width. So W is going to equal 6 minus 2. The width is going to equal 4. So I've got a length of 6, a width of 4, and I can double check this. And I remember the area needed to equal 24. Well, area is length times width, so 6 times 4 does in fact equal 24. So it looks like we got that all correct, even with my little mistake in the middle.
Very nice.
So.
Oh, well, I was going to say, I think I gave a problem. Actually, I know I gave a problem very similar to this to my students. And I wanted them to solve it that way because we were working on quadratics and solving quadratics. And I wanted to prove to them, look, you can do real world things with quadratics. And then they looked at me and they were like, well, the width is 2 less than the length. And they multiply to give you 24. Can't you just look at the things that multiply to give you 24? And then see which one is 2 less than, and I was like, yes, you can.
Yeah.
So you could. I like this way of solving it because it's algebra
And it's fun.
And if the number was anything different than 24, if
Exactly.
it wasn't something where you knew what the factors were so easily, right? If you didn't know the process, it would be so hard to get
That's
through.
what I said to them.
Exactly.
I said if it were not whole numbers, then you couldn't do it. So yeah, multiple ways to solve the problem. Your way is my favorite, I'll have to say. So we're going to take a little break. Let's go check out some commercials from some of our sponsors.
A lot of people think you have to be really good at numbers. And that's not really true. You do have to be good at solving problems. So we take students through all the basic fundamentals of accounting and hope to give them enough skills to go out and work in an entry-level accounting position.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
Welcome back. Hope you enjoyed words from some of our sponsors. Look into Emily Griffith if you're interested in it. It's a pretty cool place. Let's go talk to Lily. She's got some stuff to share with us.
Okay, so today we're going to be talking about our Facebook discussion, which there's a link on our Facebook, obviously. And so it's basically about this debate that has been controversial over the past years as to whether or not it is possible to determine the color of an animal by their fossil. And so today we're basically going to be talking about fossils. Fun stuff, so yeah.
I always wondered about that because I was wondering always, you know, when I was learning about dinosaurs, well, why can't they be purple? Or why couldn't they be another color? You know, that nobody knows, and I always wanted to make my dinosaurs weird colors.
And then you lost points on your test. Because you
Probably.
colored a purple dinosaur?
Probably. We'll talk to my 4th grade teacher about that.
Yeah, you had a strict 4th grade science teacher.
For
It
sure.
was greenish-brown,
Maybe.
the dinosaur.
But if
But
you'd
you
read
don't
this
know.
article back then, you could have been able to say, hey, nobody knows what color dinosaurs are.
So true. I mean, and that's one of the things, though, is that all of our facts and our information when it comes to all of this is always being updated. So, you know, what I learned in 4th grade, however long ago that was, we'll not say,
Right.
you know, is updated information at this point. So.
Yeah, I think actually one of the hardest things about science or teaching it is getting across just the basic idea that so much of what we know is based on these observations that we've made, but there's a lot that we don't know. There's a lot we haven't figured out. It seems like math, right?
It's not set in stone
It's
yet.
not set in stone like math. Right?
So
Oh, that is
funny.
so solid. What a good fossil joke.
Crack myself up.
Did you
But it
get
is
any-
true. It is always being updated. So it used to be actually that the oldest dinosaur fossil known was, and I don't even know how to say it, the Eoraptor, I would guess. And that was 228 million years old, and that was in Argentina. But recently they found in Madagascar, they found a prosauropod that's 230 million years ago. So an extra 2 million years older than this one. So we are constantly updating that information.
Yeah, I was actually reading that most fossils, which makes sense, are hard tissues, shells, and bones. And I'm actually like really into climbing. And one of the things I always thought was funny is a lot of the climbing areas are from old like rivers or water based. And so you'd be climbing and see like 60 feet up a random just shell, kind of lodged like shell outline from where there used to be a shell.
You're like, these are the mountains.
But
Why
it's
is
so
there
long
seashells?
ago, yeah.
Right.
Like what was a snail or like a shell doing here?
Makes a lot
That
of
is
sense.
so cool,
yeah.
right?
Yeah.
Well, and really the mountains of Colorado, especially the Front Range, just as you're entering the mountains, that's an area where as you start to go into the mountains, you're going through sedimentary layers that were laid down, and a lot of them were laid down during a time period where Colorado was underwater. It was part of what was called the Intercontinental Seaway. And so there was a sea that kind of went through what is today North America.
It's
And
so hard to picture.
isn't that just wild to
Yeah.
think about, right? And so there would have been seashells all over the place. Those sediments get buried over time. They get turned into stone. And then eventually the process that lifted up all of the Rocky Mountains brought up and made those things visible so that Nate could climb on them.
Yeah, thank you,
Nice.
Rockies.
Yeah, right? Well, I think, my favorite thing about fossils, or one of them, has got to be that you can really tell a good story with them, right? There's this really cool event that happened, well, I don't know if it's cool for everyone, but 65 million years ago, there was a mass extinction event. And during that mass extinction, the majority of dinosaurs went extinct. And you can see, if you look before that event, you actually end up seeing tons of dinosaur fossils. If you look after that event, you see many more mammals, and you start to see the dinosaurs disappearing. And so what happened at that point was there was an asteroid that hit the Earth. At least this is what we say today. As best we can tell, it was an asteroid that hit the Earth, killed off most of the dinosaurs, and then created space effectively for the mammals to rise. So mammals like ourselves might never have had the opportunity to exist
weren't.
if we hadn't killed off the dinosaurs 65 million years
I
ago.
remember learning that from Fantasia. It was a very, very brutal scene, to
that
be
is a
honest.
very
It was
sad
really
educational.
scary and
You were very
sad.
right about that.
It was awesome. I love that movie.
That's true.
Well, sounds
All right.
like we had a caller actually.
do
We
have
should
a
probably
caller.
get to them.
Okay, so let's talk to our caller. Are you there?
Hi, yes, I am here.
Hi. Do you have a question for us?
Yes, I have a science question.
Oh,
nice.
great.
That's awesome.
So, biologically speaking, what is the difference between a producer and a consumer?
Okay, yeah, sure. So producers and consumers. This is actually a really cool thing about biology, I think. Most of the energy on the Earth that animals use comes from the sun, which is sort of a strange thing to say. I can imagine that if you think about the food that you eat in the morning, like for breakfast, you probably don't think of that as energy coming from the sun. But this idea of consumers and producers is based in this idea. So if you're a producer, what that means is that you make your own food in your body using the energy of the sun. And if that sounds like a living creature to you, that's probably sounding like plants. So plants are called producers because they can use the energy of the sun and then water and carbon dioxide to make their own food. And that food that's made is sugar. So all sugars that are made by plants using the energy from the sun. Other animals, of course, have to eat each other in order to get that energy, or eat plants. And so they're called consumers. So we have consumers and producers. And then to go maybe just even a level deeper, there's this idea that there are different levels of consumers. So the lowest level of consumers, we call them herbivores because they eat only plants. And they're getting all of their energy from plants. And again, those plants get their energy from the sun. The plants are the producers. Then there are second level consumers. Those second level consumers get their energy by eating the first level consumers, by eating the herbivores. So we can imagine, say, a mouse that might be feeding on seeds would be a first level herbivore. And then maybe a fox that's feeding on a mouse would be a second level consumer. Does that make a little bit of sense to you guys?
Can you be a producer and a consumer? Or would it just be levels of
That is a really good question. Not normally, but there are some really weird examples of this. Like, for example, if you think of a Venus flytrap.
I was just going to say that.
Nice.
I was just going to say that.
So
one.
a Venus flytrap is one of these really rare examples where it makes its own sugar using its leaves for photosynthesis, producing sugar with the energy from the sun. But then also Venus flytraps eat flies. And so they get some of their energy from flies also. And there are a few other plants like that that do that. And then there's also maybe one last thing that needs to be said, which is that not all producers get their energy from the sun. The vast majority do. But there is this small group of producers which make their energy from chemicals. They're called Chemo Autotrophs. And an example of them would be bacteria that lives deep inside of a cave that never sees sunlight but is able to live. And it's able to live because it can actually take chemical energy from rocks and use that energy to live on. But these are very, very rare creatures. They're always bacteria. The vast majority of producers, we're talking about plants.
Okay, thank you.
Does that make sense?
Yeah, that made a lot of sense.
Awesome. Good to hear.
Great. Thanks for calling.
Uh-huh. Bye.
All right, we're going to take a minute and remind you, give you another chance to answer the trivia question. So I think it should come up on the screen. But that trivia question again was, what makes hot peppers so hot?
Oh,
So
boy.
remember, you can call in, give us your answer at 720-424-1666.
Good. So you still have a little bit of time to get that in. And you can always guess, too. There's nothing wrong
no
with
harm in
that.
guessing.
No
And
harm
there's
in
a prize
guessing.
if you get it right.
True. Prizes are
mention that.
great. So there we go. All right, well, let's go back to Lily and get some more questions answered, or as many as we can. So
Okay.
what do you have for us?
We have an easy math problem, and it says to find the mean, median, and mode and range for the following list of values, and it says 13, 18, 13, 14, 13, 16, 14, 21, and 13. Blah.
14, 13, 16, 14, 21, and 13. Okay, I got you on this one. We had to find mean, median, mode, and range. Okay, mean, median, mode, and range. All right, so I'm going to start with the easy ones and work my way to the more difficult ones. Part of the issue with mean, median, mode, range, not all that difficult to actually calculate any of these. It's just knowing the difference between all of them is sometimes difficult. So what I like to do before I even start is I like to put my numbers in order because that helps with the mode. That also helps with the median. Oh, and it also helps with the range. So it's just very helpful to have them in order. So we'll start with our lowest number, 13. And I also always cross them out as I go when I write them down, just to make sure I have them all. That's one of the most common issues with mean, median, mode, range is just copying and making sure you have the whole list of numbers correct. So it looks like I have 4 13s, and I have 14, another 14, and then my next highest is 16, and then 18, and then 21. So I've got my numbers in order. Now, let's go with our mode. So mode is, the way that I remember this one, is the mode, oops, when I underlined it, it disappeared, whoops, mood. All right, let's try this again. All right, so mode, this one occurs the most, and that's kind of how I remember that one. It's not the most number, it's the one that occurs the most. So if you kind of see here, and actually by putting our numbers in order, it makes it a lot more obvious which number occurs the most. It's 13 because we have 4 13s. We only have 2 14s and then only one of the rest of the numbers. So our mode in this case is going to be 13. I'm going to write that next to it because it's the one, again, that occurs the most. The median, if you think about the road, when you drive on the road, The median is the thing that's in that concrete block that's in the middle of the road. So the median is the one that's in the middle. One of my middle schoolers, when I taught middle school, used to tell me, well, I always remember median because it sounds like medium, small, medium, large. Great, that's another way to remember it too. It's the one in the middle. So the way that a lot of times people teach it is we just cross things out until we find ones in the middle. So 2 on either side. I put dots next to them in case you need to use the numbers later. So I've got 4 on the left, 4 on the right. It looks like 14's in the middle. So there is our median, is the one in the middle. The range is probably the next most difficult. It's the difference between the highest and the lowest. It's basically telling you how far apart your data is from each other. So lowest and highest, lowest is 13, highest is 21. Our data from the lowest to the highest, the distance, is we just subtract to find distance. So 21 minus 13, we get 8. So that means our range is 8. So our data, the range from lowest to highest, is 8. Mean is probably the most difficult one, and I'm going to use the calculator just for time's sake. But the way that we find the mean is the average. We add all of our numbers up and divide by however many numbers we have. So I've got 13 plus 13 plus 13 plus 13 plus 14 plus 14 plus 16 plus 18 plus 21. And that gives me a total of 135. And then we want to divide by the number that we have. So we have, if you count the number of data we have 9 pieces of data. So we're going to take that number divided by 9. And we get 15. And the way that you can kind of check your mean is that it should be close to, it should be a number that is close to all of your numbers. So if you got something like 45, that would not make sense for your mean because it's not close at all to any of those numbers. So our mean here is 15, which again should be close to all of our numbers. So there you have it. That's how you're going to calculate. These are called measures of central tendency, and that's how you calculate all 4 of our measures of central tendency.
Is it fair to call the mean the average? Is that always the same thing, or is there ever a difference between those two things?
Oh, the mean and the average?
Is it the same?
They're
totally?
the same thing, yeah. Same exact thing. You got it.
All right, thanks for that. We're going to go back over to Lily for the trivia question.
So once again, the trivia question was, what makes hot peppers so hot? And the answer to that was capsaicin.
I didn't actually know about that before today, but basically there's this Scoville scale where it measures different peppers. So if you've had, for example, I think we were talking earlier about the ghost pepper, which is really high up on the Scoville pepper scale, or if you've ever had bell peppers, not very spicy, they're actually kind of sweet, very low on the Scoville pepper scale. And what it does is actually measures the pungency or like the spicy heat of chili peppers, and it measures them in Scoville heat units. So they use those units to actually measure how spicy a pepper really is.
Oh yeah, one of the weird things about that is, it sounds so scientific to say, okay, so the habanero pepper has a score of like, what, 700,000 or something like that. It seems really scientific, but actually what they're doing is they've got a group of 5 taste testers who are supposed to be expert capsaicin or spice taste testers, and these are the people who are trying to perceive the spiciness. So they will dilute the spiciness a huge amount in water, and then they'll feed people the water with this, and it's how quickly they recognize that the spice is there. That tells you how spicy it is, and there's a good system for it. Yeah. But it's not as though it's being measured in the same way as, let's say, temperature, which is a very factual thing. The Scoville scale could be wrong based on maybe if one person's taste buds are more sensitive than another person's taste buds.
There's a lot of variables.
There's a lot of variables involved.
That makes sense.
You know what I love about peppers, though, is there's a lot of uses, not just putting it in food. So one of the things I found interesting is actually when you eat a pepper, you start to sweat. And it's because it's speeding up your metabolism. triggers this kind of like thermodynamic burn. So you can actually burn more calories if you're eating peppers. So if you don't feel like working out, just eat a
I will
handful of
take that into
peppers
consideration.
and just sit there and sweat.
You're
So
just
one thing
telling
I was
people to
thinking-
not exercise. It's no good.
That's
You're just
true.
giving people a reason to
The
have heart
Scoville
disease.
testers must be pretty thin.
Yeah,
They're
Yeah,
just doing
right.
this
If
all
they're
day.
ripped, then it's working.
Yeah, right.
it's true.
So I was looking on this here, and I don't see. Have you guys ever had shosito peppers?
No, I don't think so.
No.
Okay, so I don't like spicy things at all, but shosito peppers, most of them are not spicy, but every 1 in 20, and I actually looked it up because I kept getting spicy ones when I'd order them. I'd be like, wait, what? I thought they weren't spicy. Just 1 in every 20 is spicy.
Huh. That is so
Not all
interesting.
of them.
I used to live in Spain, and there's a kind of pepper there called pimientos de padrón, and it's the same thing. It's kind of Russian roulette with
it
the
is.
peppers.
Wow.
And then the locals love it because they love getting foreigners to come and try them, and they watch you while you eat them because they're waiting for you to get
Oh,
the
that's
spicy one.
torture.
Yeah.
Yep. I didn't know that they were spicy, and then I ate one and was like, what happened?
Wow.
So yeah.
Well, have you guys ever had the experience of drinking water after you eat something really spicy and it makes it worse?
Yeah.
Has that ever happened?
Milk.
Yes.
Well, just to go a little sciencey on you.
Do it.
So capsaicin is hydrophobic, meaning it does not bond with water. So if you're imagining if you eat something really spicy and then you drink some water, what you're doing is you're washing away all the food that's in your mouth and all the food particles except for the capsaicin,
That's awful.
which kind of like oil doesn't mix with water. And so to get spiciness off your tongue or out of the inside of your mouth, you're supposed to drink something that has fat in it.
Like dairy.
milk?
Like
dairy,
dairy.
that's what I always
Right,
use.
so milk is a great
Milk.
way to go.
Eating yogurt with Indian food, I always do that
Very
because
smart.
it'll help me get through the spice because I love Indian food, no spice though.
Indian
That's actually
food
why
is
yogurt is a
amazing.
common part of that cuisine, is
I was
because it
wondering
helps to
that,
balance
actually.
out the spiciness of that food.
Makes a lot of sense.
Yeah.
So I don't like spicy. Do you guys like spicy?
I love spicy.
I wouldn't say I love it, but I definitely prefer a little bit of spice.
A little bit. You're not going Carolina Reaper.
I'm not getting crazy
or,
with
yeah,
it, but I
okay.
like the kick to it a little
So
bit.
is there something, can you build your tolerance to spice? Does anybody know if you could do, because I feel like I've gone through periods of time where I'm good with spice and I can eat really spicy stuff, but if I quit eating it for a while, I just can't deal with it.
Yeah.
That is a great question. I don't know if I can answer that scientifically, but just as a human being, I think so. It seems like
can.
if you condition yourself to eating that, or I know
have-
friends that have lived in like Mexico and gotten very used to
Yeah.
spicy food, they come back and they can eat spicy food like they've never been able to.
And it would make
I have
sense
read that you can
why-
actually condition yourself
Oh,
to
nice.
get a little bit more used to it, which actually makes sense because
Why some
culturally,
cultures-
some
right.
people are just, they can eat.
Right.
See,
Whatever
I've never
is
been
possible.
able to eat spicy food. My parents are Mexican and Puerto Rican, and I've never been able to. No,
Maybe you
they always
haven't
make fun of
conditioned
you haven't been training
Yeah,
hard
they
enough.
Apply
always make
yourself,
fun
Lily.
of me. They're like, "What kind of Mexican are you? You can't
I
eat
have a
spicy
friend
food."
that
I don't
if there's
know. I don't even
anything
go to
spicy-
Chipotle. It's too spicy for me.
Yeah.
I literally,
wow.
Cholula is like the only hot sauce I can handle without it being too spicy for me.
Which isn't really.
Yeah, it's
Which
a-
is
it's
not
spicy.
anything
Gotta
at
train
all.
yourself,
It's
I guess.
pretty little.
I have a
Very
friend that
interesting.
anything he eats that even has like a hint of spice, he just starts sweating and gets a little.
See, that's me.
That's me
at
I'll do it though. I'll
Santiago's.
do it, but I'm
Ugh, Santiago's is no bueno for me.
bueno. Oh, bueno. All right. Well, very interesting. No trivia winner today. Sorry. You guys got to call in to at least guess. Come on. But you have another chance tomorrow to answer our trivia question. We will be back again to answer all of your homework questions as well tomorrow from 4:30 to 5:30. You can catch us live then. So thank you again for joining us today. Oh, also, if you do have questions between now and then, get your questions in. You can, Lily will answer the questions. So get your questions in to Facebook. You can also watch us on YouTube. So watch our previous show. If you loved us today, watch us again on YouTube tomorrow, or search for Denver DPS TV and you can watch us then. So catch you tomorrow. Thank you, Sam, for joining us. Great
Yeah,
group
great to have you
today.
on.
Yeah,
Love
absolutely.
having you. And we'll see you tomorrow.
Thanks.
Bye.